Bismillahirrahmanirrahim. The Honorable Madam Tricia May M. Ramos, Mr. Benj Go Febros, and Madam Pershena G. Leona as the keynote speaker today. The Honorable Alaf Committees Institute of Global Professionals, and my beloved ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. Good evening, Indonesia, and Om Swastiastu. Welcome to our Institute of Global Professionals free webinar. Thanks for joining with us in this wonderful evening and stay with us till the end. I am Winnie Puspitasari Suparto as the host webinar today and a member of Institute Global Professionals. Ladies and gentlemen, first of all, let us pray and praise to Allah Subhanahu wa Ta'ala, because of His grace and mercy, we can join together. And let us greet and pray to our beloved Prophet Muhammad Sallallahu Alaihi Wasallam, who had brought us to the path of light. Well, ladies and gentlemen, here, as we know that IGP, or Institute Global Professional, is an educational institution programmed to provide social work. We believe that Institute of Global Professionals serves students, community resource, providing holistic social work and education for create a proficient generation. So, we expect that you are getting a little bit benefit in personal and professional life. Well, ladies and gentlemen, join us for the international webinar 763 entitled Dealing with Fraction with three keynote speakers. They are Madam Tricia May M. Ramos, Mr. Brent Gofabros, and Madam Pearl Shayna Giliona. They are from Philippines. So for the first speaker, we invite Madam Tricia May M. Ramos. Hello, Madam.
Hi, ma'am. Good evening.
Good evening, ma'am. Okay, ma'am. It's time for your presentations. Time is yours. And good luck.
A pleasant evening to everyone on the different platforms that we are streaming from the Institute of Global Professionals. My name is Tricia May M. Ramos. I'm an instructor at Tarlac Agricultural University here in the Philippines. Before I start my session for today, I would like to acknowledge and I would like to thank Sir Kaushik Datta, the Chairman of Institute of Global Professional, as well as Sir Nestor Nuesca, the Director of Institute of Global Professionals here in the Philippines. For today, this topic will be dealing with or about an essential skill in mathematics, which is dealing with fractions. Our session will be divided into three parts, where the objectives are: first one is examine different researches, journals, books, to have an overview on why students have difficulties in dealing with fraction. What are the reasons, and what implications can we draw from these researches, these journals and books, so that we could apply them in our own classroom instruction. For the second one, we'll be having the use of graphic organizer to solve the addition and subtraction of fraction, wherein this will be discussed by our second speaker, which is Mr. Bench Fabros. And the last one is apply different techniques to perform operations in fraction, which will be presented by our third speaker, Ma'am Pearl Leona. In this regard, the content of our webinar for this evening are as follows. The first one would be the rationale of the seminar. The second one is using graphic organizer in dealing with fractions. And the last one is the different techniques in solving fractions. To start with, we all know that fraction is one of the hardest lessons that students in the primary age or in the primary years of education. To rationalize this, fraction is one of the most hardest lesson in mathematics, like I said, to deal with. We all know that this topic is an indispensable part of our life, even without realizing it. We always or we constant use it in our day-to-day activities, such as slicing this pizza in front of us, or baking a chocolate cake, or simply looking at the quarter or the minutes in a clock, wherein we try to estimate how many minutes, how many seconds, and all. With this, fractions, we all know it plays a key role in mathematics since it is involved in many branches of mathematics. It is used in probability, it is used in rate and proportion, and it is even used in algebraic reasoning. However, the main question is, why do we have a hard time dealing with fraction? If we all know that it is a fundamental skill in mathematics, but why do we have the difficulty to learn this part of mathematics? Even if we know that it has been rooted back to the ancient times, ancient civilization, it is used until this current times. However, it still poses a major problem whenever we are learning mathematics. Then, if it is rooted way, way, way back then, why is it so hard for pupils to learn and represent fractions? In that case, here are some of the researches that we could gather in order for us to have an overview why we have difficulties. What are the reasons? What are the difficulties that students encounter in learning fraction? Okay, let's start off with a research in 2007, wherein fraction or fractional learning is noted historically that students face difficulty. Among the most complex mathematical concepts, children have a hard time dealing with this lesson, even up to high school. They also identified, the researchers also identified several factors that contribute to this difficulty. And some of which were also taken into consideration. And other researchers have furthered their instruction, or rather have furthered research on this topic in order for us to grasp what is the reason behind it. The first one is students have low procedural and conceptual knowledge about fraction. There are two main cases here, procedural knowledge and conceptual knowledge. Let's start with the idea of conceptual knowledge. Students have difficulty in differentiating a whole number from the idea of a numerator and a denominator. Okay? They have a difficulty in viewing that it is not a two separate whole number, but rather it represents one idea only. On the part of procedural knowledge, we all know that if we are dealing with the basic operations of fraction, there are several procedures in order for us to come up with the final answer. In here, students mix the procedure, or rather, students do not know which is the first step, which is the second step, and all. As a result, the fraction or the answer is wrong. That is the first one. For the second one, we have difficulty in the graphical representation of fraction. When you say graphical representation, these are the visual representation of fraction. Let's say, for example, you are presenting this to the class. Teachers usually present figures, geometrical figures, in order for us to present the concept of fraction. However, in most cases, students and teachers are accustomed in using only a circle to represent a fraction. And we are not able to do it in different forms, such as using rectangles, such as using other geometric figures. Then, the researchers found out that because teachers only use, or most of the time use, circle to represent fractions, students have this meaning, or they are tied up to the mathematical concept, or they are tied up to this concept that fraction is only in circles. Thus, this research emphasizes that teachers need to use different modes of geometrical representation in order to enhance students' visualization process, because that is the problem. Okay? The third one is the inability to comprehend the problem. The researchers found out that the findings in their studies indicated that whenever whenever students have low comprehension skills, it results in a difficulty in analyzing the problem. It results in a difficulty to identify what is the given, what is the operation involved, and what do they need to do. Due to this, students cannot create the mathematical expression. Students cannot create the mathematical sentence in order to solve the fraction. And lastly, the over-reliance on calculators. This research indicated that using calculators, or an over-reliance of paper and pencil computation, thus, to a large extent, curb the development of number sense, because we are used to just inputting the given in a calculator. The procedure in solving fractions is oftentimes neglected. As a result, if the students do not have a calculator at hand, the problem will not be solved. Okay, the implication here that the over-reliance on these tools does not enhance the students making sense of numbers. It inhibits the development of intuitive knowledge, especially on the context of estimation. Therefore, if these are the reasons why students have a hard time dealing with fraction, what is the implication to us educators? What shall we do? And here are the 4 implications that we could do as educators. The first one is to boost the independent seat work and homework according to SUAN of 2008. Independent seat work and homework should be provided by teachers. This is an important opportunity for students to apply the knowledge, to practice the skill that they have learned inside the classroom or during our classroom instruction. These will also increase the fluency. It will also increase retention because through practice, students will have a higher retention on the conceptual and on the procedural knowledge of dealing with fractions. The second one is to improve the mental representation of fraction. In here, we are or we should provide concrete examples in the context of the students. When I say in the context of students, it must be situated in the experiences, in the environment of the students. Thus, it would increase students' engagement since they have already the background knowledge on the materials that we are using. The use of concrete examples to students can help them visualize the problem at hand. If we could bring pizza inside our classroom, if we could bring blocks inside our classroom in order for us to divide it, then we could use it in order to improve the mental representation of our students. Aside from this, we could stimulate the process skills of our students by giving out HOTS question or higher order thinking skills questions to our students to help them develop, to help them process the idea of fractions. We could allow group activities so that they could share ideas and eventually process the idea of fraction or doing the operation. Connecting this to the idea on teachers should find ways to strengthen conceptual and procedural understanding of students. Here, as teachers, as educators, we must find a deeper sense on the idea of fraction. We must dig deep in order for us, for our students to have that connection, to have an idea that, fraction is important. Okay? This is designed especially for our students to help them to gather the knowledge that they need in order for them to understand the idea of fraction. Experiences can contribute to this one. And lastly, we must use localized manipulatives in teaching fraction. The idea of realistic mathematics education is to allow our students to manipulate real life manipulatives in order for them to understand the lesson that we are teaching. Here, we could use indigenous manipulatives if in the area bamboo is an indigenous material, if we could get and we could use it inside our classroom and use it as an instructional material to present the idea of fraction, then we could use it. Okay? Indigenous manipulatives materials facilitated students transition to the idea of symbolic, to the idea of algebraic representation of fraction into a more concrete one. Okay, this would help our students to know that there is an evidence that fraction is used in real life context. With that, in line with this implication, my co-speakers for tonight will be presenting some techniques following these various implications that I have presented in order for us to present fractions inside our classroom in an easy and fun way. To end my session for tonight, let me leave you with the quote of Confucius that says, "It does not matter how slowly you go, so long as you do not stop." It only means, or it only reminds us, teachers, educators, that it's all right for our students to take a step by step, day-to-day chance in order for them to understand the idea of fraction. We do not pressure them. We do not box them in the idea of just writing 1/2 plus 1/2 or 3/4 plus 5/6. Then they need to have the final answer. We do not box them. We allow them to explore. We allow them in their own pace as long as they do not stop learning the idea of fraction. With that, I would like to thank again the Institute of Global Professional for having me for the fifth time. Thank you very much.
Wow, thank you so much, Madam, because you have done to share your knowledge and your experience about these materials. Okay, well, ladies and gentlemen, for the next speaker, we invite Mr. Benjko Fabros. He is instructor one. Okay, hello, Mr.
Hello, ma'am. Good evening.
Good evening. Well, time is your presentation tonight. Good luck.
May I check if my screen is visible already?
Yes, sir.
Hello, everyone. Mabuhay. Greetings from the Philippines. First of all, I would like to thank the Institute of Global Professionals, or IGP, for giving me this opportunity to share in this platform. So at this juncture, I am pleased to share to you one of the ways on how to deal with fractions. By the way, I am Benjgo Fabros from Tarlac Agricultural University, Philippines. So at this juncture, again, I'm pleased to share to you one of the ways on how to deal with fractions through the utilization of graphic organizers. Utilizing graphic organizers is one of the way or method to use to improve the conceptual understanding of the learners. So to define what a graphic organizer means. So when we say graphic organizers, is also known as a visual map and is rooted and firstly coined as advanced organizers by David Ausubel in 1969, where he said that it serves as a bridge connecting the gap among learners' pre-knowledge and what they have to learn. So, graphic organizer is a broad term and has an abundant and diverse meaning. So, in the literature, there are so many graphic organizers, and each graphic organizer is unique in nature, and each one of them has its own use. But for the sake of this discussion, we will deal only on two types. So these are the visual model. When we say visual model, it's a graphical representation of numbers and also a great way to assess understanding. And the second one is the number line. When we say number line, pertains to a straight line with numbers placed at equal intervals or segments along its length. Now let's proceed in discussing addition of similar and dissimilar fractions utilizing graphic organizers. So are you ready? Now, I have here two figures. When you saw this figure, what words or word that come first into your mind? Or what word or words can you associate when you see this kind of figure? So help me in unlocking what is that word. So you are free to use our comment section and join me in answering. So let us all challenge our minds this night. So this, when you see this, and there's what we call fraction. So this is a fraction, and if we're going to name this with the orange shade, this is 4/5. And the second one is 2/5. Now the question is, when we see the 4/5 and 2/5, what kind of fractions they are? They are similar fractions. So when we say similar fractions, these are fractions having the same denominator. So that's the meaning of similar fraction. Now, this type of graphic organizer is a visual organizer. The second figure is what we call the number line. So here in number line, the first figure represents 3/10, and the second figure represents the 7/10. So as you can see here also, 3/10 and 7/10 is an example of a similar fractions. So very good. Now join me in answering these some numbers, or this I will present to you. So for the direction, add the following fractions. I'll be presenting here, and then join me also in answering these operations or these questions. 1/4 plus 2/4 is equal to 3/4. 1 and 5/7 plus 1/7 is equal to 1/1 and 6/7. Next, 2 and 1/3 plus 3 and 1/3 is equal to 5 and 2/3. And lastly, 9/17 plus 6/17 is equal to 15/17. So very good. Now let's challenge again our minds by answering this worded problem. For our example number 1, it says here, the Student Council of the College of Education was able to collect 2/5 kilogram of manure and 1/5 kilogram of rice husk for the beautification of their college. The question is, how many kilograms of garden essentials that the Student Council collected? So here in the Philippines, we have the steps to follow in order for us to answer a specific problem successfully. So for the first step, what is ask? So what is ask? Based on the problem, how many kilograms of garden essentials that the Student Council collected? The second step is, what are the given? So the givens are 2/5 kilogram of manure and 1/5 kilogram of rice husk. Next step, what is the number sentence? So since we are dealing with addition, our number sentence here is 2/5 plus 1/5 is equal to n. Then later on, we will find what n mean, or what is the answer to the representation of n. And lastly, how are we going to solve the problem? We will get the sum of 2/5 and 1/5. Now, to use or to utilize the graphic organizer, specifically the visual model, let us represent the numbers or the fraction into a visual model. So 2/5 in a graphic organizer or visual model, it goes like this. Next one, 1/5. So in 1/5, if we represent that in visual model, it goes like this. Now, since we are adding these two visual models, based on this, what is the next figure? Like this. Now, based on this figure, your student now will count the shaded part that will serve as your numerator. And the total number of partitions serve as your denominator. So the shaded part is 1, 2, 3. And the total number of the partition is 1, 2, 3, 4, 5. So that means our answer here is 3/5. So that's the use of graphic organizers. Next, let's add fractions with visual models. Now, I will present the visual models and then we will transform it into a fraction. So here, for our first addend, it says here, as you can see, the shaded parts is 2, 1, 2. And the total number of partition is 1, 2, 3, 4, 5. So our first addend is 2/5. Let's try again the second addend. The second addend is 1, 2, and then 1, 2, 3, 4, 5. 2/5 also. Now, based on the sum or the combined shaded part, what is our final answer? So let's just count the number of shaded part and then the total number of the partition. So the shaded parts are 1, 2, 3, 4. And the total number of partition is 1, 2, 3, 4, 5. So if that's the case, then our final answer is 4/5. Next, let's try again. We have our first addend, second addend, and sum. Let's count first the total number of partition. So that means these are your denominator. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 total partition. That means that will serve as your denominator. And the shaded part is 1, 2, 3. So our first addend here is 3/10. Now, what is our second addend? Let's just simply count. 1, 2, 3, 4, 5, 6, 7. And then we know that a while back, our total number of partition is 10. So, 7/10. And based on our sum, and based also combining the shaded parts, what is our sum? So our sum is 10/10 or 1. Okay, for next one, let's try to answer or let's try to add using number line. So here's our number line. So in number line, as you can see here, from 0 through 1. So our first addend, we will just simply count first the total number of lines that will serve as our denominator. And then the number of shaded is our numerator. 1, 2, 3, 4, 5, 6, 7, 8. So our denominator is 8, and then our shaded part is 1, 2, 3. So 3/8. So one of the misconceptions in utilizing the number line is they start counting at 0. But it's not. You start at 1. So let's try again this second addend. So 1, 2, 3, and the denominator 1, 2, 3, 4, 5, 6, 7, 8. So it means our second addend is 3/8. Combining them, based on the sum here, it's 6/8, or we find the lowest term, 3/4. So as you can see also here in the graphic organizer, you can see that there are 3 parts. Next, let's try again to use number line. So for the first addend, let's count first the total number of partitions that will serve as our denominator. 1, 2, 3, 4, 5. So it means it's over 5. Now it's time to find the numerator through the shaded part. 1, 2. So it means our first addend is 2/5. How about the second addend? Anyone who would like to try? You are free to use our comment box. 1, 2, 3, 4. So 4/5. Now, as you can see here, when you combine the first addend and second addends, it transcends, or it move beyond the one. So we're going to count first the shaded part. So 1, 2, 3, 4, 5, 6. So it's 6. And then we know that our denominator a while back is 5. So what will be our answer? 6 over 5. And 6 over 5, we can transform it into a mixed number. It will become 1 and 1/5. So let's have this one. For the direction, it says here, give the least common denominator or LCD of the pair of fractions. So for letter A, 1/4 and 1/6, it's 12. How about 2/9 and 1/8? What is the LCD of 2/9 and 1/8? It's 72. Correct. How about this one? 2/3 and 3/4. What will be the LCD? Correct. It's 12. And lastly, how about 1/5 and 1/7? It's 35. Very good. Now let's have our second example. For our second example, it says here, Sharon gave 3/4 liter of water and 5/8 liter of soda as her contribution in their outing. The question is, how many liters did Sharon brought? Now, in order for us to successfully find what the problem is looking, we have our steps or guides in answering. The first step is what is asked. Based on the problem, how many liters did Sharon brought? And how about what are the given? 3/4 liter of water and 5/8 liter of soda. Next one, number sentence. Since we're still using addition, 3/4 plus 5/8 is equal to n. And lastly, how are we going to solve the problem? How? We just simply get the sum of 3/4 and 5/8. Now, let's use graphic organizers in finding the answer. So our first given is 1/2. Then we will transform that into a visual model. So it goes like that. Our second given is 2/5. So if we're going to transform that, it goes like this. Now, based on these two visual models, we can now create our sum given this one. But the question is, how are we going to find the answer if the one is 1/2 and the other one is 2/5? So that is a question for us. Since a while back, we already knew or we already learned the concept of LCD. Now that's the time we can use the LCD, the concept of LCD, in answering this problem. So how? Since we have 1/2 and we have 2/5 a while back, and based on that, based on the figures, we can come up that the sum will look like this. Since we learned the concept of LCD, we can now transform this 1/2 into 5/10. So our LCD of 1/2 and 2/5 is 10. How about in 2/5? It becomes 4/10. Now, we have here, we transform the dissimilar fractions. When we say dissimilar fractions, these are fractions that that are not the same in denominator. So we transform that dissimilar fractions to similar fractions for us to find the sum. So looking at these two models, 5/10 plus 4/10, combining them, we can come up that it looks like this. Now, for the student, they can just simply count the total number of the region and the shaded part. Then that will be the final answer. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our final answer here is 9/10. That's how to deal with the dissimilar fractions. Let's try this one. We just simply count. So this is 11/6. This one is 10/3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And then the total number of partition is 3. 1, 2, 3. So based on these two, the first two figure, combining them, it can come up like this. And then we learned a while back the concept of least common denominator. So what is the common denominator for 6 and 3? So based on our final visual model, it is 6. So our final answer here is 31/6, or we can convert that into a mixed number. It becomes 5 and 1, 6. Let's try again another example. So let's count for our numerator, and then later on, let's count the total number of each partition or each model. So for the shaded part, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's 16 plus 3 is 19. So that 19 will be our numerator. How about our denominator? Let's count 1, 2, 3, 4, 5, 6, 7, 8. So 19/8. How about the second addend? Let's find first the shaded part. So 1, 2, 3, 4, 5. So that's the numerator. How about the denominator? 1, 2. So 5/2. Now getting the LCD of 8 and 2 will come up to 8. So adding, combining the shaded part, we will yield, or we will obtain the sum, which, how many? 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 8 plus 8 plus 8. So, and then 2, 4, 6, 7. That is 39/8, or 4/7/8. Let's have our final example. So our final example using a number line. So based on the first addend, our numerator is 1, 2, 3, 4, or 1 and 1/3. So it goes beyond 1, so we can use that as our whole number as 1, and then 1, 4, and then the total number of partition before the first whole number is 1, 2, 3. That's why over 3. So 1 and 1/3. How about this one? Let's count first the total number of partition. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So a total of 8. As you can see here, it goes beyond 2. So we knew that our whole number starts with 2. So 2/7/9. And then combining them, our sum is what? 4 and 1/9. So as you can see also here in the picture or in the model, this is a first, second, third, and fourth. And then we have an extra one. That's why 1/9. So 4 and 1/9. And last, so our first addend, 1, 2, 3, 4, 5, 6, 7. Or in a mixed number, we can see that this is 2 and 1/3. How about the second addend? 2 and 4/5. Now, obtaining or getting or finding the LCD of 3 and 5, we can find 15. So as you can see here, there are a lot of partitions. So combining them, we can see that 1, 2, 3, 4, 5, and then 1, 2. So 5 and 2, 15. So that's how we utilize the visual models and number lines in solving addition of similar and dissimilar fractions. Now to generalize the process on how to add the similar fraction, we first change the similar fractions to similar fractions before adding. That's the process of LCD, or the least common denominator. And then, if we are already in the form of similar fractions, we can now add the numerator and simply copy the denominator. Add the numerator and then write the sum over the common denominator. And lastly, with mixed forms or mixed numbers, we just simply add the fraction first, then the whole numbers, and then add the results. And if it's not in a final form or it's not in a lowest term, we will reduce the answer to find the lowest terms when needed. So that's the process on how to add dissimilar fractions. Now to challenge our minds and to apply what we have learned, let's try this one. So it says here that Richard took 2/3 hour to paint a portrait. This was 1 hour shorter than the time he took to paint scenery. The question now is, how long did he take to paint the scenery? Before we show the visual answer or visual solution to this problem, let's first find what is asked. So what is asked? How long did he take to paint scenery? What are the givens? 2 hours and 1/2 hours. And the number sentence, 2/3 plus 1/2 is equal to n. And then how we're going to solve the problem is just simply get the sum. So let's try to solve. So we have 2/3 and we have 1/2. Now, since they are in dissimilar form, we find first their LCD. We will get the LCD. So the LCD is 6. So 2/3 become 4/6. And then 1/2 becomes 3/6. Now, since we are in the form of similar fractions, it's easy for us to get the final answer. So 4/6 and 3/6, combining the shaded parts, we can have this one. So we will count 1, 2, 3, 4, 5, 6, 7. So for our numerator is 7 and our denominator is 6. So 7/6 or 1 and 1/6. And that's how you utilize graphic organizers in solving addition of similar and dissimilar fractions. So thank you so much. Once again, I am Benchigo Fabros from Tarlac Agricultural University, and thank you for this opportunity.
Okay, thank you so much, sir, for your valuable time because you have done to share your knowledge and your experience about dealing with fractions related to mathematics. So amazing. Well, ladies and gentlemen, for the last sessions, for the last speaker, okay, we invite Madam Proshena Giliona. Hello, Madam.
Good evening, Miss Wendy, and to all the viewers there. Good evening as well.
Okay. Okay, it's time for your presentation tonight. Oh, time is yours.
Okay, thank you. Let me share my screen first. So, once again, to all the viewers and in the different platforms of IGP, good evening. Whatever greetings is applicable on in your area. So, I am the third speaker for tonight's seminar. dealing with fractions. So I am Pearl Sheena G. Leona from University of Rizal System Tanay Campus here in the Philippines. Okay, so the first speaker, Miss Trish, talked about the researches related to the difficulty of fraction in general and what implications do they have on the educators field. So the second speaker, Sir Bench, talked about the 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 tool that we can use in dealing fractions. Okay. Now, before we proceed with the topic that I am assigned for tonight, did you know that the lines that separate the numerator and denominator is called vinculum? Okay, which is also the word used to describe a connecting band of tissue, such as that attaching a flexor tendon to the bone of a finger or toe. So, quite literally, this term is at your fingertips. So, going back to the topic for tonight, so I am here with you tonight to share 3 tips for teaching fraction operations. So, very specific fraction operations. So, for tip number 1, we have to understand why. Okay, why do students have difficulty when it comes to fraction operations? Okay, so a while ago, Ms. Trish had discussed the difficulty of students in fractions in general, and now for fraction operations. Now for tip number 2, review and assess fraction foundations. Okay, and tip number 3, use the 3 vehicles to teach fraction operations. I will tell you all about this later on. Okay, so first, so if your students struggle with fraction operations, well, you are not alone. So many rely on tricks like keep, change, what else? We also have flip, but never develop conceptual understanding. So these students have a hard time applying these concepts in their real life experiences as they forgot what they learn much more quickly. So, ensuring students are fluent in fractions is essential for their overall success in mathematics. So, fraction understanding provides the basis for decimals. We also have percents and ratios. They also allow students to understand proportions, slope, and rational numbers. Okay, so when students don't master this fraction in early as in elementary grade, they tend to struggle through middle school and high school. In like for example in algebra, statistics, and even calculus. So to help your students, first you'll want to know why they're struggling with fraction operations. The actual answer is different for each student, but here are the common pitfalls to look out for. Okay, so why do they struggle? First, one reason students struggle with fraction operations is that fractions are just less intuitive than whole numbers. So students constantly add and subtract whole numbers in their everyday lives, even without realizing it. On occasion, they even multiply and divide. For example, if they ride their way home, okay, from the school, so they ride public utility vehicles and they pay the fares, or even they even if they eat on their own canteen, they pay for their meals. So these are examples wherein they can apply the whole number operations in the same manner. This also goes with fractions. So while they know what it means to eat half a cookie in cooking, measuring 1/2 cup of flour, they don't usually operate with fractions. Many think as a half, just a half, not as a number with 1 in the numerator and 2 in the denominator. Okay? So second reason is that they haven't mastered foundational concepts, namely the meaning of fraction itself and the whole number of operations. So if you ask your students to multiply 3 by 13, do they envision an array of, like for example, objects wherein you can multiply 3 objects by 13? An area model, skip count by 10 3 times, then skip count by 3 times, or did they just stack and calculate? So students who can visualize full number operations can build on their understanding of division to understand a whole cut into 4 parts, like the image on the screen. So they can extend the idea to add one fourth to another fourth eventually, or to multiply a fifth by 3. But since many students lack these conceptual foundations, they just see these fractions as one number atop another. So the more tricks and procedures they learn, the more likely they are to forget them or to use the wrong trick to the wrong problem. So instead, it becomes a collection of math facts, math formula, random rules, and secret symbols. Okay. Next, next difficulty. Who Even students who understand whole number concepts may struggle with fractions. So in early elementary, students focus on mastering the base 10 system. What is this base 10 system? They count by tens, combine tens and ones, and break up numbers by place value to operate, just like the image on reason number 3. Okay, so it's all about making tens, breaking tens, and using zero as a placeholder. But fractions aren't built on tens. Fractions can split a whole into thirds, a sevenths, or tenths. And as the denominator changes, the size of the unit, not the number, changes. As thus, the units needed to make a group as a whole. Okay, so fractions also contradict the rules students learn from whole numbers. When you multiply 3 by 5, the result is larger than both. But when you multiply fractions, like for example, when you multiply one third with one fourth, the answer is smaller than both fractions. And in some situation, like for example, if you multiply one fifth by fourth, it creates a product in between the two factors. So when students have strong conceptual foundations, they can generalize what they know about whole numbers to understand fractions. But without this understanding, they might feel like they're starting over with a whole set of rules. Okay, so as an educator, we know that in mathematics, we have to connect one concept to another so that our students can advance to the next level. Okay, so next, the first step to helping your students with fractions, as I've said a while ago, is to learn why they struggle. Next is to have specific actionable steps to address those challenges. Then, make sure your students really understand the meaning of a fraction. Then connect that to what they already know.
Hello, ma'am. Are you there? Oh, ladies and gentlemen, maybe she has bad connection, so we're still waiting for you, ma'am. Okay, well, ladies and gentlemen, I remind you, don't forget to share, like, comments this page on a Facebook, Institute of Global Professionals, and don't forget to like, share, and subscribe YouTube channel Institute Global Professionals because your attachment encourage us to do better and best service to our lovely audience. So we still wait for the last speaker. Maybe bad connections, guys. Okay, hello, ma'am.
Hello, Miss Windy. Am I clear?
Okay, yes, ma'am. Is it clear your voice so you can continue your presentation?
Yes. I'm currently having a technical difficulty here in the Philippines.
Yes,
Okay, so let
no
me continue
problem.
my presentation.
Yes.
So again, the first step is to helping your students with the fraction operations and to learn why they struggle. The next is to have a specific actionable steps to address those challenges. And the next, make sure your students really understand the meaning of a fraction and then connect that to what they already know about whole number operations. And then this next tip will come through. So we have to review and assess fraction foundation. So simply put, a fraction itself does not describe the size of the whole or the size of the parts. A fraction tells us only about the relationship between the part and the whole. So a denominator tells us how many pieces a whole is divided into, just like on your screen. A numerator tells us how many of those pieces we have. Though the numerator is on top, it doesn't mean much unless we know the denominator. That's why I teach my students fractions from bottom up. So that's the technique that I am currently using when I teach fractions to my students. Okay, so at some point, as you can see on the screen, I think this is usually in grade 5 here in the Philippine curriculum. Students learn that a fraction can also be thought as a quotient. So the result of a numerator divided by a denominator. So 3 divided by 4 is just the same as 3/4. So these can be shown visually as 3 wholes, as you can see on the pie chart on the left side of the image. Okay, so each split into 4 equal parts. And then with the parts regrouped into a single fraction, which is also shown on your screen on the right part of the image. Okay, to assess their understanding, students must be able to do this without much direction from the educator. So if you have to tell them to cut this or to shade this, they don't get the concept. They are just drawing what you are told them to do. Okay. Next, we have the three vehicles to teach fraction operations. So these three vehicles are inquiry-based lesson models that promote conceptual understanding. So they can be used to teach almost, I think, any math concept at any grade levels, either in elementary, middle school, or high school. Okay, so in your screen, you have there the representations of mathematical ideas. So the vehicles are built on multiple representation theory. The idea that any mathematical concept can be represented in 5 different ways. So physically, we have them there physically, visually, symbolically, conceptually, and verbally. So, we can define fluency as the ability to translate a mathematical idea among all 5 representations. This includes translating an expression into a visual model or explaining in words how a manipulative works. So, the 5 representations that I mentioned a while ago define how mathematical ideas can be represented. So, they have vehicles, each uh, we as an educator teach students how to translate among them. So as you can see on your screen, for scale models, the first vehicle, we have there the physical and visual representation. For the number sentence, we have the symbolic representation. And for the story problems, we have the contextual and the verbal representation. Okay, so again, we have 3 vehicles to teach fraction operation. Um, I guess I have to tell this. There are plenty of tools that we can use to teach fraction operations. So these are just few of them, few of those that you can use on your own classroom. So first we have the scale models, we have the number sentences, and the story problems. So first model is the scale model. So it combines physical and visual representation, also known as the concrete and pictorial, as both serve a similar purpose. They represent the size of numbers and the meaning of operation. Okay, so scale models are useful for building and assessing conceptual understanding. So to use scale models as a teaching tool, as you can see on your screen, these are just some of the examples. And I think Sir Bench had already showed this a while ago, the some of the models, okay, the visual models. So first teach the principles of reading and creating scale models, such as this one. Then use the models as tools for helping students to learn through inquiry. So, for example, if students understand fractions and whole numbers, when it comes to multiplication, they can use their modeling skills to discover fraction, okay, in any operation like addition, subtraction, multiplication, and division, even without direct supervision or instruction from their educator or teacher. So it's important for students to create their own models rather than just interpreting models in the textbook made by the teachers. So reading models is helpful, but it isn't enough to achieve fluency. So, for example, we already use these models on your screen, on your own classroom. So, let them explore what is more applicable to their learning style, what is easier for them to learn this fraction operation. So, let them explore. Okay, so final vehicle for today is the number sentences. Okay, so number sentences, equations, inequalities build on the concepts developed with the visual models to support development of abstract understanding. Okay, so number sentences allow students to manipulate expressions and work on multiple steps, making them much more useful than calculating with algorithms. So I use number sentence proofs to help students learn number sentences and connect them to the other representation. So as you can see on your screen, this is an example of number sentence. So both illustration is just one half, but the representation that we are using, the operations that we use are different, but the visually they are just the same, one half. Okay. So story problems, the third vehicle, help with the application skills and mathematical language. So in my case, I teach students to use Polya process for solving word problems. I think this is also applicable to other expertise aside from education. So it is designed as a four-step method to solve all kinds of problems. The steps are first to understand the problem, then make a plan, execute a plan, and look back and reflect. So, because the method is very simple and generalizes well, it has become a classic method for solving problems. In fact, the method is applicable to all areas as I've said a while ago. Okay? So, although the method appears to be a straightforward method where you can start with step 1, step 2, and followed by 3 and 4, the reality is that you will often need to go back and forth through the 4 steps until you have solved and reflected on a problem. So, this approach, story problems approach, emphasizes the importance of using multiple representations to solve word problems. This vehicle comes last among all the three because students can use scale models and number sentences as tools for solving word problems. As you can see on the screen, we already have there the first vehicle, the pie chart, the and then we also have there the number sentence, the 1/2 times 3/4, and then 3 over 8. Okay. So all in all, again, there are plenty of tools that you can use on your classroom. It depends on you as a teacher, which tools makes you more comfortable on teaching on your own classroom, and as well as what is more uh, comfortable for your students on their own learning style. Okay, so because the teaching of fractions is important and because fractions are often not well understood even by adults, a recap of the big ideas is needed. Hopefully, you have recognized that one reason fractions are not well understood is that there is a lot to know about them, from part whole, from division construction, and understanding relationship across area, across length, and the models that I have mentioned a while ago. So many of these strategies may not remember as an educator. Many of these strategies may not have been part of your own learning experience, but they must be part of your teaching experience so that your students can fully understand fractions and be successful in algebra, not just in algebra, but beyond mathematics. Okay, so I think that all wraps up our presentation for the night. Thank you again. I'll give the screen back to Miss Wendy. Hello,
Okay,
Miss
thank you so
Wendy.
much, Madam, because for your giving us your valuable time, because you have done to share your knowledge and your experience about dealing with fractions, especially for mathematics. Nice. Well, ladies and gentlemen, after the speaker's speech, please thanksgiving on the basis of the speaker's speech and presentation. That's excellent. So, I remind you guys, don't forget to share, like, comments this page, and please like, share, and subscribe YouTube channel Institute Global Professional. Well, ladies and gentlemen, for the next sessions, we open quiz competition. So let's start. Okay, ladies and gentlemen, I'm so sorry for these mistakes informations. Well, these sessions, there is no quiz competitions. Well, for the next sessions, we open question and answer. Okay, so if you have another questions for these materials tonight, please write your questions, your name and your country. Okay, guys, any questions for these materials tonight? Okay, guys, I remind you, don't forget to share, like, comments this page, and please like, share, and subscribe YouTube channel Institute Global Professionals. So for this session, we open question and answer. If you have a question, please write your name, your country, and your questions. And then I will invite the speakers will answer it. Or maybe there is no question. Okay, here we have one questions from Mr. Gap Wagan Aguila. Okay. Hello, speaker. Could you suggest fun ways to introduce fractions to students, especially those who do not show any interest in math? So, for these questions, I invite for the first speaker answer it. Time is yours.
Yes, ma'am. Hello. Good evening, Sir Gab. As for this question, a while ago I have said different implications on how we could help our students deal with fractions. Us educators could use manipulatives for our students, real life or indigenous materials manipulatives for our students to use. In this case, students could use or could mix and match different blocks, different objects in order for them to visualize what fraction is all about. Aside from this, we could use video presentations. We could use um, like what Ma'am Pearl said and Sir Bench uh, presented a while ago, we could use different scales, graphic organizers, for us to present the idea of fraction. Instead of just plain presenting the numerator and the denominator using our chalk and chalkboard, we could use a varied materials in order for us to present the idea of fraction. Also, it was said in the research a while ago that we should increase the mental representation of our students. In this case, like I said, we could have varied materials for us to present the idea of fraction instead of just the symbolic representation of fraction.
And also, Miss Wendy, if may I add, hello, Miss
Yes.
Wendy. Yes,
Yes,
to
ma'am.
answer to uh, to add some ideas to what Miss Trisha has have said. So not just in school but also in our own home, there are plenty of commercial products that we can use to introduce students to fractions. Like for example, as far as I know, we have the game called Play Facto. Okay, so there are also plenty of applications online that we can use as a game inside our household. Okay, so we not just as the educators but also the parents or the guardians can also make the students more interested on on the concepts of fractions.
Can I add to the question number one?
Okay, sir. Time is yours.
Okay, one of the reason why students feel difficult in mathematics is that they don't see the relevance in their life. So to make that more appreciative for the students, we will make mathematics, most especially fractions, relevant in their life. One of the easiest way and convenient way to introduce fractions to our students or to the young learners is through by having a milk drink. So in a they put milk, they put sugar, and so on and so forth. That's one of the convenient way. It should be started at home. You can find them at home, and they also need to learn that mathematics is everywhere. So do not afraid to learn mathematics because learning math is fun. That's all.
Okay, thank you so much, Madam and Sir, for great suggestions. Okay, next, for the second question from Mr. Sunday. Okay, the questions to Sir Bench. Okay, the question is, sometimes I see a negative symbol beside the fractions bar. Does that mean both the numerator and the denominator are negative, or it is affecting just only the numerator? Name Sunday O Oladokun. Oh, kan. Okay, from Nigeria. Okay, thank you so much for your question. So I invite Mr. Batch to answer.
Thank you, Sir Sunday, for your question. So technically, in lower mathematics, when we saw a negative number between the numerator and the denominator, it means that it it applies to all. It applies to all. But in higher mathematics, there are instances that it only in the numerator, but it also affect the entire. But to introduce it to the young learners, because the fractions will be introduced to the young learners. So as simple as that, it can affect.
Okay, thank you, sir. So, any question for the third? Okay, well, there is no questions. Thank you so much, sir and madam, because you have done to share your knowledge about dealing with fractions this night. Well, time is over. Thank you so much. Uh, Ladies and gentlemen, hopefully we can learn something new and we can implement for this life. Please leave a review, recommend, support, share on our page if you learn something or we help you a little bit, and please share the information with your friends. So I think enough. Thank you so much for joining with us. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. See you. Okay, ladies and gentlemen. For the last, I wanna give you informations about how to get a certificate in this webinar. Well, today's certification process, please click www.eduigp.com, and here certificate code required. Today's program name is dealing with fractions, and the code or the password is IGP0432. Okay, the password is IGP0432. Okay, without coding, no one is eligible for a certificate. So, with coding, you can claim your certificate anytime, and without an account on our website, you can visit, but you cannot do anything functionally. So, this webinar on 20 August 20 and 21, please note or screenshot or take note how to get certificate code. A certificate international webinar this night. Okay. Okay, so thank you so much guys, and don't forget, fit your skill. Okay, thank you so much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. And good evening everyone.